Are you curious about what's new in Terraform 1.4? Then this video is for you. What's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to another episode of Terraform Tuesday. Today, we're going to be talking about what is new with Terraform 1.4. There's two new features we're going to cover. The first one's pretty quick. We're going to talk about the new flag that's been added to Terraform Workspace Select, which solves a problem some of you may have encountered in the past, and if you haven't, well then you don't have to worry about it now. And the other thing is a new managed resource type that's called Terraform Data that is there to serve two functions. One, it's going to replace your usage of the Null resource, and two, if you happen to be using the lifecycle block with replace triggered by, this is a way to use input variables or local values as that value to replace by. So we're going to cover those two today. Let's start by covering the easy first one, which is the new flag that has been introduced for the Terraform Workspace Select. Now, I'm not going to go into full detail about what workspaces are, why you might want to use them. Just suffice to say that creation of a new workspace is a separate command, Terraform Workspace New. If you try to select a workspace that doesn't exist with Terraform Workspace Select, previous to 1.4, you'd get an error. And the way around that, if you were running this in a pipeline where the workspaces might not yet exist, was to either run Terraform Workspace Select, get that error, and then handle it through bash scripting or something, or run Terraform Workspace New every time and then just accept the error that the new workspace already exists. So either way, it wasn't great. You had to handle that error outside of Terraform. So what they've done is added a new flag. Let's go check it out. Okay, in the Terraform Tuesdays repository, I've got a new folder that's 2023-0403 Terraform data, since that's the focus of this, but we'll talk about the workspace command first. So I've got a very simple configuration here. I've got one resource. This is foreshadowing for the next section. That's called Terraform Data. And the only argument there is input and is taking the value of Terraform Workspace. And then we're going to show that as output, what workspace we're currently using. So let's go into that directory called Workspace Example. And I'll run a Terraform apply with the auto approve flag just to get some data in there. Okay, and since we haven't created a workspace yet, we're using the default workspace, and that's what we see in the outputs. Workspace is set to default. Now let's try to select a workspace that does not yet exist. So I'll say Terraform Workspace, select is the command, and we'll call it test. Okay, I get back an error. Workspace does not exist. If you were scripting this out, you'd get a non-zero exit from this command, and then you would catch that non-zero and create the workspace with a Terraform Workspace New. But we don't have to do that anymore. There's now a new flag in here, which is -or create, which basically tells Terraform, if this workspace does not yet exist, please create it for me. Now that we run that same command with the flag, it says, hey, I created and switched to that workspace for you. And if we run another Terraform apply in this brand new workspace we just created, we can see that the workspace is now test. Now, if we are not focused on that, if I go back and go Terraform Workspace Select, go back to the default workspace, and I run that same command again with the -or create, it'll just switch directly to the workspace and it ignores the fact that it already exists. So if it doesn't exist, it creates it. And if it does exist, it just switches to it. That's pretty cool. So if you run into this specific problem, you can remove that error handling from your bash script and just add this flag if you're using Terraform 1.4. Now let's talk about this weird Terraform data thing that I threw in here. The other new feature that's been introduced is the Terraform Data Managed Resource. And I need to give a little context here in what a managed resource is, because it's kind of a new concept in Terraform. Now, if that's not of interest to you and you just want to know how this replaces the null resource or it's used in that lifecycle block, go ahead and skip to that chapter. But for the rest of you, I just want to provide a little context around providers to begin with and what it means for it to be a managed resource. So let's start with providers in general. Now, as you probably already know, providers are simply plugins in Terraform that allow it to interact with different services. There's an AWS provider, there's an Azure provider, there's a Google and a Kubernetes provider. Way back in the old days of Terraform, before there were over 1,000 different providers, there's only like 3 or 4. And during those early development days, the providers were actually baked into the core Terraform code and binary. So the Terraform executable that you got would have the plugins, they weren't even plugins at that point, it would have the providers baked directly in. And that was fine at the time. There was like 3 or 4 of them, but there were some downsides to that. As the number of providers grew, the size of the Terraform executable also grew. Got a little bit big. In addition to that, the patches to those providers, any updates that needed to happen, also meant that a new version of Terraform needed to be published. And that was a pain. Like every time a little update came out, a new version of Terraform had to be released. So around Terraform 0.10, they made the decision to split providers out as their own plugins and make them available eventually on the public registry. So when you initialize Terraform, what you were actually doing as part of that initialization process was pulling those plugins down from usually the public registry or whatever source you had specified, and it would put them in a local directory that it could invoke as the Terraform main executable did its work. So now the plugins were totally separate, but there was one exception. There was a data source, and still is a data source, called Terraform Remote State. And it didn't really make sense to break that out into its own provider that was up on the registry. So what they decided to do was create a built-in provider inside the Terraform executable that just had that one managed data source in it, Terraform Remote State. And what that allowed you to do was read another configuration's state data as input, as a data source, and then use it in some way. And that allowed you to create disassembled Terraform configurations where you could have multiple configurations that sort of plugged into each other by binding the output of one as input or data source for another. Now here comes along another managed object. In this case, it's a managed resource called Terraform Data, and it's also baked directly into the Terraform executable. So if you happen to be using this resource and nothing else, when you run Terraform in it, it won't download any plugins because it's already baked into Terraform. It's only, as far as I can tell, it's only the second object to be in that provider. So just a little interesting context there on what's kind of special about this resource versus all other resources in other providers. Now let's talk about its actual utility in terms of 2 different applications. The first application we're going to look at is a replacement for the Null resource, which is part of the Null provider. The Null provider's been around for a good long time, and it really only has 2 things in it. It has the Null resource and the Null data source. The Null data source was a way to transform data during a dynamic operation, which was then replaced by local values. So while it still exists, all the functionality is there for local values, so no one uses the data source that was in the Null provider. So the only thing left was Null resource. Now, what is Null resource for? Null resource doesn't actually create a resource per se. It creates an entry in the state file to track some values. And it's used to fire off provisioners. Now, if you're not familiar with provisioners, first of all, that's awesome. Good for you. Second of all, HashiCorp does not like provisioners and would prefer that you didn't use them. And third of all, I'm not going to get on my soapbox right now about why you shouldn't use provisioners. That's a video for another time. But basically, provisioners allow you to run a local script, a remote script, or copy files to a remote system. Now, sometimes you want that bound to a particular resource, say a virtual machine that you've spun up. But sometimes you need it to do that outside of a specific resource, maybe anytime you add another node to a cluster or something. So the Null resource has a triggers argument that tracks other resources in your configuration, and when one of those changes, that forces a recreation or a destroy and create operation on that Null resource. Destroy and create are the only time that provisioners are fired. So by forcing the Null resource to recreate itself whenever one of those other attributes changes, it forces that provisioner to run again. So that's what the Null resource was intended for. But like I said, it was the only resource in this provider that lives outside of Terraform, kind of a pain. So data source is there to replace that same functionality, but now HashiCorp no longer has to maintain the Null provider. Now the Null provider is still supported as of today, but you can probably expect that the Null resource and the Null provider are going to be archived in the not too distant future. So if you are using the Null resource today, let's take a look at how you can do the same thing with the Terraform data resource. Okay, let's start with a simple example. I'll go ahead and open up my main.tf that's in the simple example. And what I've got here is an input variable called change_me. I've got the Null resource here, and the trigger on this, the triggers takes a map of key value pairs, and the value has to be a string, and it's tracking whether or not that string is changing. And you can have multiple entries in here. Right now, I'm tracking any changes to the input variable change_me. So if that value changes, that will cause a recreation of the Null resource. And I also have a provisioner here that echoes out the value of that change_me variable. Then I have below that the implementation of this same exact thing using the Terraform data resource. So in this case, the argument is triggers replace instead of triggers. And that takes a single value of undetermined object type. So it doesn't have to be a string. It could be a map. It could be a list. As long as something in that value changes, well, it has to be a single value, but you can have a map or an object or a list. But as long as something inside that value changes, then that will trigger a recreation of the Terraform data resource, and it will kick off that provisioner, in this case, local exec. So let's go ahead and run this configuration. Go ahead and open up the terminal, and we'll go into that directory, and we're going to run a Terraform init. And when I do that, you'll see, let me scroll up a little bit here, it downloads the Null provider because we're using that in our configuration. But it doesn't download the built-in because it's built into Terraform. Hey, that's convenient. All right. Now let's go ahead and run a Terraform apply. With the auto approve and see what it creates. Now this is the first time I'm running it, so I need to provide a value for change_me, and I will provide the value taco. Okay, so it created two resources, the Terraform data resource and the Null resource. And then it ran the local exec for both. So it echoed out taco. Okay, very simple, right? Now let's see what happens if I change the value. And I'll do that by adding the -var here, and I'll set change_me equal to, why not? Burrito. I'm changing my mind here. So when I do this, because I'm changing that value, that forces a recreation of both resources. So we're seeing that here. Terraform data.main is being destroyed and then created, and it runs the local exec provisioner, and the Null resource does the same thing. So what we have here is a one-for-one replacement of the Null resource. If you're using it today, replacing it with Terraform data will be no big deal. And now you no longer have that external dependency on a separate provider. You don't have to download that provider plugin anymore. And it might even run like a little bit faster, because I know reaching out to a separate executable does eat up like a couple CPU cycles. It's not going to be significant, but there will be a difference. So that's one thing that Terraform data is able to do. The other thing is it is able to be used as part of a lifecycle block, and that is because of another portion of the Terraform data arguments. That's the input argument that we saw used earlier with the Terraform workspace. So let's take a look at that example and how it can be leveraged with replace by. The Terraform data resource stores data within the Terraform state file. It acts like a resource. And so you can leverage that functionality to work with the replace triggered by argument that goes in the lifecycle block. Now, if you're not familiar with what this does, replace triggered by was added in Terraform 1.2, and it goes inside the lifecycle block for a resource, and it tracks other resources within your configuration. And if any of those things change, or a particular attribute of them changes, then that will force a recreation of the resource that is tracking it in the lifecycle block. And you can reference an entire resource, or you can reference a specific attribute of that resource to track. This is for situations where there might be a logical link between two resources that should force a recreation, but there's no actual direct link between them in the Terraform configuration. So you need to imply that in some way so Terraform knows when this resource is updated, this one needs to be recreated. And that logic was common enough that they added a whole argument for it called replace triggered by. The thing about replace triggered by is the only acceptable values in the list are resource addresses, not input variables and not locals. So if you wanted to use an input variable to control the replace triggered by lifecycle, you couldn't do it. But now you can. So Terraform data can be the intermediary between that input variable and the resource with the lifecycle block that you want to recreate. Let's look at what's in this configuration. I've got a variable called simple string, and I have a resource, Terraform data, that's going to be storing that simple string in state data using the input argument. So it's tracking what the value is that was submitted and storing it in state data so it can be used when it's calculating the plan for what it's doing with its resources, when it's creating that execution plan. Then I have a second resource here that's taking input, so it's storing the data that's stored in the locals, simple local, which is not really important, but I need to throw something in there for input. And then for the lifecycle, it's looking at the value of Terraform_data.source. So it's looking at that other resource. If anything changes about that other resource, then it's going to force a recreation of this resource. So let's run through the same process again. So let me clear this out and go into that directory, replace by. We'll do a Terraform init. But you'll note, since we are not using any providers that are external to the Terraform built-in, it didn't have to download anything. That's kind of nice. Okay, now let's run a Terraform apply with the auto approve. And that will create our two resources, the two Terraform data sources. Okay, that's all set and ready to go. Now let's run a plan, but we're going to change the input of our simple string. So I'll add in let's change this from apply to plan. We'll add a variable in here and we'll say simple string and set that equal to cheddar and see what it plans to do. Okay, this runs very quickly because it's not reaching out to any other resources, but it has two things that it's trying to do. One to add and one to destroy. Let me run that again so it's a little easier to see because I think it got cut off in the screen. So Terraform_data source is going to be updated in place because I'm updating the input value from cheese to cheddar. But Terraform data destination is going to be replaced because that replace triggered by was changed. Now, nothing about the actual object is changing because I didn't change the input that was associated with it. But if I run a Terraform auto approve, if I run this as an apply instead of a plan, it will recreate that resource. Now that could be used for any resource type, right? It doesn't have to be my sort of hackneyed creation here. But this is a good example of showing how you can use Terraform data resource as an intermediary to make use of that replace triggered by block. So those are the two main uses that the Terraform data resource was created to solve. Now, if you allow me to pontificate for a second, I don't know any of this for a fact, but my guess is what happened is they introduced the replace triggered by in Terraform 1.2, and then people started saying, well, hey, I'd really like to trigger this with an input variable or a local value or something like that, but you don't allow me to do that. And to get around that issue, they came up with the idea of this Terraform data resource. And when they did that, they realized, oh, we could also use this to replace the null resource, and we're kind of tired of maintaining the separate null provider anyway. That's a whole code base that we're maintaining outside of Terraform for just one resource that's in there. Why don't we move the equivalent resource in and just use Terraform data to really kill two birds with one apply, if you will. So I think that's what happened behind the scenes and why it has this sort of dual nature to it. But it's pretty interesting, and I think there could be some other potential applications for the fact that you can now store arbitrary data inside your state using the Terraform data resource. I'm curious to hear what you think and any potential applications you can think of. So let me know down in the comments if there's something that, turns on a light bulb for you. You're like, oh, this solved this problem that I'm having, because I'm really curious to see what people might use this for. That's going to do it for me for today. Thank you so much for watching. Subscribe if you like. Give me a like if that's cool too. And until next time, stay healthy, stay safe out there. Bye for now. I just realized that whole video, Mr. Taco was falling down. That's no good. I don't like it when Mr. Taco falls over. I'm going to go fix him. That's better. Mr. Taco needs to stand up. Bye.